Effective lighting installation hinges on several key factors. Clear communication, thorough preparation, and a solid understanding of lighting specifications can significantly reduce complications. Firstly, prioritize detailed communication. When engaging clients for lighting installations, emphasize the importance of clearly conveying their lighting preferences and specific requirements. Understanding their vision from the outset can prevent mismatches and ensure satisfaction. Secondly, conduct a comprehensive site inspection. Before purchasing any lights, meticulously assess the existing conditions, electrical wiring, and insulation. Identifying potential challenges beforehand, such as limited space or specific insulation types, allows for informed decision-making. Thirdly, provide specific guidelines and recommendations. Offer clients concrete recommendations for lighting fixtures, including their IC rating, wattage, and compatibility with insulation. These guidelines empower clients to make informed choices that align with their needs and safety standards. Fourthly, refer to lighting specialists. Direct clients to reputable lighting suppliers and consultants who can provide expert assistance in selecting suitable lights based on the specified requirements. Their expertise can prove invaluable in navigating the complexities of lighting options. Fifthly, request detailed product information. Ask clients to provide comprehensive details about the purchased lights, including the model number, wattage, and IC rating. Having this information readily available allows for verification and ensures the lights meet the necessary specifications. When dealing with incorrect lighting purchases, a polite but firm approach is essential. Explain the situation clearly and professionally to the client and the lighting store. Avoid accusatory language and focus on finding a resolution. Next, provide documentation to support your claims. Show the client and store consultant the relevant building codes or manufacturer's instructions that specify the required IC rating. Presenting concrete evidence reinforces the need for compliant fixtures. After that, explore alternative lighting solutions that meet the necessary specifications. Be prepared to suggest alternative options that address the client's needs while adhering to safety standards and building codes. Subsequently, maintain professionalism throughout the process. Stay calm and maintain a positive attitude, even in frustrating situations. A professional demeanor can help diffuse tension and facilitate a productive dialogue. Finally, consider the return policy. Check the lighting store's return policy and inform the client of their options for returning the unsuitable lights. Understanding the return process can alleviate financial concerns and streamline the resolution. To further enhance efficiency, consider offering lighting packages. These packages include installation services and pre-selected lights that meet specific requirements. By offering curated packages, you can streamline the selection process and ensure compatibility. Additionally, establish relationships with reliable lighting suppliers. Partner with suppliers who can provide technical support and ensure the availability of suitable fixtures. A strong supply network can significantly improve your ability to source compliant lighting solutions. It is also important to educate clients. Inform clients about the importance of proper lighting and the potential hazards of using incorrect fixtures, especially in areas with insulation. Empowering clients with knowledge promotes informed decision-making and ensures their safety. Understanding IC ratings is crucial when selecting recessed lighting, particularly in insulated ceilings. The IC rating, which stands for Insulation Contact Rating, indicates that the fixture is designed to be safely installed in direct contact with insulation. Non-IC rated fixtures generate heat that can ignite nearby insulation, posing a fire hazard. Always verify the IC rating before installing recessed lighting in insulated areas. When selecting recessed lighting, wattage limits are also a critical consideration. Exceeding the maximum wattage specified by the fixture manufacturer can lead to overheating and potential fire hazards. Always adhere to the wattage limits indicated on the fixture label. Using lower wattage bulbs or LED equivalents can help reduce heat generation and improve energy efficiency. Building codes play a significant role in ensuring safe lighting installations. Familiarize yourself with local building codes and regulations regarding recessed lighting, including requirements for IC ratings, fire-resistant junction boxes, and proper wiring techniques. Adhering to building codes is essential for preventing electrical hazards and ensuring compliance. Electrical safety should be the paramount concern during any lighting installation. Always disconnect the power supply before working on electrical wiring. Use appropriate tools and techniques to ensure safe connections and prevent electrical shocks. If you are unsure about any aspect of the installation, consult with a qualified electrician. Ventilation is an important factor to consider when installing recessed lighting. Insufficient ventilation can trap heat and lead to premature bulb failure. Ensure that the recessed housing has adequate ventilation to dissipate heat effectively. Consider using LED bulbs, which generate less heat than incandescent bulbs. Inspecting existing wiring is a crucial step before installing new lighting fixtures. Look for signs of damage, such as frayed insulation, loose connections, or corroded wires. Replace any damaged wiring to ensure safe and reliable operation. Consider upgrading to newer wiring if the existing wiring is outdated or inadequate for the new fixtures. Selecting the right type of wire connectors is essential for making secure and reliable electrical connections. Use wire connectors that are specifically designed for the gauge and type of wire being used. Ensure that the connectors are properly tightened to prevent loose connections, which can cause overheating and electrical hazards. Before installing any lighting fixtures, carefully inspect the junction box to ensure that it is in good condition and properly grounded. The junction box serves as a protective enclosure for electrical connections and provides a grounding path for safety. Replace any damaged or corroded junction boxes. Grounding is a critical safety measure that helps to prevent electrical shocks. Ensure that all lighting fixtures and metal components are properly grounded according to electrical codes. Connect the grounding wire to the grounding terminal in the junction box and to the grounding screw on the fixture. When working with electrical wiring, always use appropriate safety gear, including insulated gloves and safety glasses. Insulated gloves protect against electrical shocks, while safety glasses protect your eyes from debris and sparks. Before making any electrical connections, double-check the wiring diagram to ensure that the wires are connected correctly. Incorrect wiring can lead to malfunctions, electrical hazards, and potential damage to the fixtures. Follow the wiring diagram carefully and double-check your connections before energizing the circuit. After completing the installation, test the lighting fixtures to ensure that they are working properly. Turn on the power and check each fixture to verify that it illuminates correctly. If any fixtures are not working, troubleshoot the wiring and connections to identify the cause of the problem. Consider using a voltage tester to verify that the voltage is correct at each fixture. An overvoltage or undervoltage condition can damage the fixtures and shorten their lifespan. Use a voltage tester to measure the voltage at each fixture and ensure that it is within the specified range. When installing dimmer switches, choose dimmers that are compatible with the type of lighting fixtures being used. Some dimmers are designed for incandescent bulbs, while others are designed for LED bulbs. Using an incompatible dimmer can cause flickering, buzzing, or premature bulb failure. After installing dimmer switches, adjust the dimming range to optimize performance and prevent flickering. Some dimmers have adjustable settings that allow you to fine-tune the dimming range and eliminate any flickering or instability. If you are unsure about any aspect of the lighting installation, consult with a qualified electrician. An electrician can provide expert advice and ensure that the installation is done safely and correctly. Remember to follow all applicable building codes and regulations. Building codes are designed to ensure the safety of electrical installations. Consult with your local building department to ensure that your lighting installation complies with all applicable codes and regulations. Consider the energy efficiency of the lighting fixtures. Energy-efficient lighting fixtures can save you money on your electricity bill and reduce your carbon footprint. Look for fixtures that are ENERGY STAR certified and use LED bulbs. When choosing LED bulbs, consider the color, temperature, and light output. Color temperature is measured in Kelvin and affects the appearance of the light. Light output is measured in lumens and affects the brightness of the light. Select LED bulbs that provide the desired color temperature and light output for your specific application. Consider the ambience and mood that you want to create with your lighting. Different types of lighting can create different moods and atmospheres. Use a combination of ambient, task, and accent lighting to create a well-balanced and visually appealing lighting scheme. Ambient lighting provides overall illumination, task lighting provides focused light for specific tasks, and accent lighting highlights specific objects or areas. Consider the location of the lighting fixtures and how they will interact with the surrounding environment. Avoid placing fixtures in locations where they will create glare or cause shadows. Position the fixtures to provide optimal illumination and enhance the visual appeal of the space. When installing outdoor lighting fixtures, choose fixtures that are designed for outdoor use and are weatherproof. Outdoor fixtures should be able to withstand the elements such as rain, snow, and sunlight. Use weatherproof wiring and connectors to ensure that the electrical connections are protected from moisture. Consider the security aspects of outdoor lighting. Outdoor lighting can deter crime and enhance the safety of your property. Install motion-activated lights to provide additional security. When installing landscape lighting, choose fixtures that are designed to blend in with the surrounding landscape. Use low-voltage lighting to create a subtle and inviting atmosphere. Consider the impact of lighting on wildlife. Avoid using bright lights that can disrupt the natural behavior of nocturnal animals. Use shielded fixtures to direct the light downwards and minimize light pollution. Consider the maintenance requirements of the lighting fixtures. Choose fixtures that are easy to clean and maintain. Replace bulbs promptly when they burn out to ensure optimal illumination. Regularly inspect the wiring and connections to ensure that they are in good condition. Heat the fixtures free of dust and debris to prevent overheating and premature failure. These tips and guidelines can help to ensure safe, efficient, and aesthetically pleasing lighting installations. By prioritizing communication, preparation, and knowledge, you can avoid common pitfalls and create lighting solutions that meet your clients' needs and exceed their expectations. Furthermore, understanding concepts such as voltage drop is paramount. Voltage drop refers to the decrease in voltage that occurs along an electrical conductor as current flows through it. Excessive voltage drop can cause lighting fixtures to dim, motors to run inefficiently, and electronic equipment to malfunction. Several factors contribute to voltage drop, including the length of the conductor, the gauge of the conductor, the current flowing through the conductor, and the temperature of the conductor. Longer conductors, smaller gauge conductors, higher currents, and higher temperatures all increase voltage drop. To minimize voltage drop, use conductors of adequate size, keep conductor lengths as short as possible, and reduce the current flowing through the conductors. Electrical codes specify the maximum allowable voltage drop for various types of circuits. Adhering to these limits is essential for ensuring safe and reliable operation of electrical equipment. The National Electrical Code, or NEC, provides guidelines for calculating voltage drop and selecting appropriate conductor sizes. In EC Section 210.19.8.1, for example, addresses branch circuit voltage drop, recommending a maximum voltage drop of 3% for branch circuits and 5% for feeders plus branch circuits. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times the length of the conductor in feet times the current in amps times the resistance of the conductor per foot divided by 1000. The resistance of the conductor per foot can be found in NEC Chapter 9, Table 8. Alternatively, you can use voltage drop calculators available online or in electrical design software. When selecting conductors for lighting circuits, consider the ampacity of the conductor. Ampacity refers to the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The electrical codes specify ampacity ratings for various types of conductors. NEC Table 310.15 B16, for example, provides ampacity ratings for insulated conductors rated up to 2000 volts based on the conductor's insulation type and ambient temperature. Ensure that the conductors you select have an ampacity rating that is sufficient for the current flowing through the circuit. Dating factors may need to be applied to the ampacity ratings to account for factors such as ambient temperature, number of conductors in a raceway, and type of load. Always consult the NEC for specific dating requirements. When running conductors in raceways, be sure to comply with the fill requirements specified in the NEC. Overfilling raceways can lead to overheating and damage to the conductors. NEC Chapter 9 provides guidelines for calculating raceway fill. When making connections to lighting fixtures, use appropriate wiring methods and connectors. Ensure that all connections are secure and properly insulated. Avoid using undersized or damaged connectors. Follow the manufacturer's instructions for installing wiring devices. When installing recessed lighting fixtures, be sure to comply with the clearance requirements specified in the NEC. Recessed fixtures must be installed with sufficient clearance from combustible materials to prevent overheating and fire hazards. NEC Section 410.16 provides guidelines for clearances around recessed lighting fixtures. When installing lighting fixtures in damp or wet locations, use fixtures that are rated for those environments. Damp location fixtures are designed to withstand moisture, while wet location fixtures are designed to withstand direct exposure to water. Follow the manufacturer's instructions for installing fixtures in damp or wet locations. When installing lighting fixtures in hazardous locations, use fixtures that are rated for those environments. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Fixtures used in hazardous locations must be explosion-proof or intrinsically safe. NEC Article 500 provides requirements for electrical equipment in hazardous locations. When installing emergency lighting, be sure to comply with the requirements of the NEC and local building codes. Emergency lighting must be powered by a separate power source, such as a battery or generator, and must be automatically activated in the event of a power outage. NEC Section 700 provides requirements for emergency lighting systems. When installing lighting control systems such as dimmers and occupancy sensors, be sure to follow the manufacturer's instructions and comply with the requirements of the NEC. Lighting control systems can help to save energy and improve the comfort and convenience of lighting systems. These additional details provide a more comprehensive overview of lighting installation best practices, encompassing technical aspects, safety considerations, and code compliance. By adhering to these guidelines, professionals can ensure that lighting installations are performed safely, efficiently, and in accordance with industry standards.